Right. Today we're going to look through several online resources that are really helpful for water resources applications. Right now I'm on the USGS National Water Dashboard. This is a key site that accumulates data from all of the gauge stations across the US. Depending on the gauge station, they're going to have different information. So typically stream flow or surface water levels. There are some groundwater stations. There's some stations that have water quality data, although it's not super common because it requires more funding from a local partner. And then there's also precipitation data that can be pulled from the site. I'm going to zoom into Southeast Ohio, but before I do that, firstly, the coloration of these sites across the nation are a visualization of the percentile of flow. And so the red and the orange ones are low flow compared to average, whereas the blue ones are high flow compared to average. So we're going to zoom in on Ohio. Now it's a little bit easier to see the distribution in sites across Ohio. And so we're going to zoom in on the site in Athens. So this is the Hocking River in Athens. And so we can get a pop-up that has the current discharge. This was 18 minutes ago, and this is normal for this time of year. So we're at pretty average flow. If I click on that, I can then go into a site page. So I'm going to open that. So this is the site page for the Hocking River at Athens, Ohio. And so what I can see is right now, this is the data over the last 7 days. And so for the time of recording, what you can see is a decreasing gauge height. So gauge height is measuring the depth of the water. This is measured near the Stimson Avenue Bridge, right behind Townsend Coffee. And then I can also look at the map of where this is. There's information about who's supporting the site, etc. And so I can also change the time span of this graph. So I can make this over the last 30 days. You can see the response to a recent rainfall event, or even over the last year. It takes a moment to load, but you can see, our hydrology in Athens is that we tend to have wetter springs and generally drier summers and falls. And so you can see that data in the springtime where we saw pretty high gauge heights, even reaching almost flood height. You can see these data are colored in black and orange. The data colored in black is approved data, whereas the orange is provisional data. The USGS develops a relationship between gauge height and flow, and until they reconfirm that and redo those correlations and check the data is provisional until they approve it. You can also do things like display the median, and so we can add median data, and we can compare these data to previous years. Right now, this graph is showing gauge height. So down here, I can also pull up discharge. So discharge is going to be the flow of that site. And so if I go back up, I can look at stream flow data over that time. And then this kind of dotted line is the median data. So you can see where for this past year, where we've been above the median or occasionally below the median. There are also a few time periods where we have estimated data, and that's where maybe the gauge wasn't functioning or there was some other servicing happening to the gauge. You can also open statistical data for today, and so you can see that for Friday, August 19th, based on 106 years of data, we can see the latest value, the lowest value, the 25th percentile, the median, the 75th percentile, the mean, and the highest value for this day in the historical record. There are data tables, and so this is the tabulated data. Typically, this isn't really that helpful unless we download it. And then there's a summary of the available data. So this tells us what data we can pull for the site and the time period for that data. And we can also pull up metadata for the site. And so that's going to be the site ID number, the latitude and longitude, the accuracy of that, all the location data, the altitude of the land surface where we measure, and the drainage area of the site, some of the aquifer data. And so this gives us more information about the site. We can also, if we scroll up, retrieve data. And so there's this button here that says retrieve data. And so we can download the primary time series, which right now is Streamflow. This will open in a separate tab. And we can also change the time span. So we can go for all of the available data, so 106 years of data in for some of the data points, and change what time series we are downloading. We can also download information about the location or the median data. So this data will open up, and you can then import that into Excel, or you can use the USGS data retrieval package in R to download data straight from these sites. All right, so that is kind of the overview of USGS National Water Data Dashboard and USGS Gauge sites. There is still a link to the legacy page, which is the former viewer before this new updated version. But most of the things that you would want to do, you can do from this new page. I'm now going to switch over to StreamStats, which is also a USGS application. When you first open it, you're going to get information and news about StreamStats. And so that's going to show things like outages or updates to the site. It's a good idea to scroll through these just to see if there's something that's going to impact your work. There have been a lot of new additions to this, things like storm sewers, other regressions and analyses that you can do, and additional locations. So we can close out of that informational window and we can zoom in again to Ohio. And I'm going to show you a few things that we use this for frequently. And so firstly, as we zoom in, we're going to get this, this prompt to click a state or a regional study area. And so we need to click Ohio. The reason why we have to do that is that this application is implemented differently for different states. So like what you can do for Ohio, you may not be able to do for West Virginia, for example. So similar to the National Water Dashboard, you can see all of the USGS gauge stations plotted here as these triangles. So if I click on this one again, this is the USGS gauge at the Hocking River in Athens. And so we could click on for the National Water Information System page or the StreamStats gauge page to get additional information about this gauging station, right? So then if we zoom in further, so let's again use this site of the gauge station in Athens to delineate a watershed. So when we delineate a watershed, what we're doing is drawing the boundaries of all the land that drains to the point that we click on the river or the stream. And so I'm going to click the delineate button to activate the delineation tool. And then because I'm zoomed in far enough, that delineation tool is activated. If you don't see it activated, then you need to zoom in more. And so we're going to click on this streamline. So this line is where we have to click right by this gauge station. I chose to go upstream of that stream because I know from personal information that that gauge is just upstream of those. So it's going to take a little while, especially for a larger basin, because there's a lot of data for it to calculate. So you'll see down in the lower right-hand corner that it's delineating the basin and telling you to be patient. All right, so now it's popped up with this basin. And so the basin is all of the land that drains to this point in Athens on the Hocking River. So what we can see, it's a multi-county area. that includes Lancaster, Somerset, New Lexington, Logan, Gloucester, Nelsonville, and many other towns and cities in between. And so you can download the basin for inclusion in a GIS database, and so that can be a really helpful thing, or we can continue. We're going to click continue, which should allow us to look at scenarios and report building. So there are some regression-based scenarios. You can learn more about these by clicking the help button. These will often take a while to run, and so I'm not going to demonstrate them, but I encourage, if any of these things are important to your work, that you explore it and use the extensive help that's included in here. The thing I use this mostly for is downloading basin characteristics. So I'm going to select all basin characteristics, but this will give me the basin centroid in the X and the Y. So these are state plane units of the centroid of this basin. The change in elevation between points 10% and 85% of the distance along the longest flow path. It'll give me the drainage area of the basin, which is one of the parameters that I use most frequently. The forest percentage, the latitude and longitude of the basin centroid, the percentage of developed land, the percentage of impervious surfaces, the percentage of water bodies and wetlands, the length of the longest flow path, and whether it's in Ohio Region A or C, which is important for some of those regression-based scenarios that I mentioned above, the mean annual precipitation, and a stream flow variability index that shows the difference between the top percentile and the bottom percentiles of flow. So I can say continue, and it will calculate those basin characteristics that I've chosen. All right, so now that it's finished calculating, I can now say open report. And so it's going to give me this report that I can download as a PDF. I can add comments to it. I can add a report title, things like that. But it's going to give me the latitude and longitude of the point that I clicked the delineation, a map of the basin, and then all of these data that I requested. And so we can see that this point drains 942 square miles of land, of which 56.8% is forested and almost 10% is developed, with 1.74% of impervious surfaces and just less than 1% of water bodies and wetlands. There's obviously some more information here, things like the average mean annual precipitation in the basin is 40.4 inches based on a long-term record. So these are all things that I could download, or I can print to paper or print to a PDF. So StreamStats can be a really helpful tool for all sorts of applications. I just showed you some of the basics, but there's a lot of really well-built documentation if you're interested in exploring more of the options. So I'm going to transition to showing you Ohio watershed data. In Ohio watershed data, we have surface water and groundwater data in the state of Ohio, but much of it is concentrated in the Appalachian part of the state. There are also reports and tools available that have long-term data, that have acid mine drainage abatement and treatment plans, and work that we've done based on the development of mine pools. HydroView is a separate online ArcGIS online tool that explores overlays of multiple data sources in the Appalachian Basin and in Miami Valley region that allows for planning of watershed implementation projects. There's also some contact information and an education tab that has some educational resources associated with this. We're going to go ahead and zoom in surface water on Raccoon Creek, which is one of the watersheds near Athens in Ohio. You can see at this view, we have a reasonably large basin. Raccoon Creek drains almost 700 square miles of southern Ohio. And so you can see that here. As we zoom in, we start getting points where data has been gathered. And we're going to zoom in to a point on a sub-watershed called Hewitt Fork, called HF010. And so HF010 is right near the Moonville Tunnel, and it's the mouth of Hewitt Fork. So Hewitt Fork was previously really impaired and now has a lot of treatment projects, or now has a treatment project about 11 miles upstream from the mouth that takes care of a lot of the acid generation that was happening in this watershed and prevents fish kills in the main stem of Raccoon Creek. So we can mouse over this site and get a description of the site. We can also click on it, we get a photo of the site, and on the left we get info about the site. And so it gives us a gradient, it gives us a site description, a drainage area, a river mile marker, and some other information. We can also see the historical chemistry data that's been collected. So you can see data up to 2022, but going back into the 2000s. And so for any of these data points, we can click and we can view that data as a one-off sort of data page. And this is a more limited data point, but there are some that have more extensive data available at them that have more lab data, as you can see down in the bottom here. So there's also a biological data tab. And so this allows us to see all the places that biology, or all the times that biological data has been collected here. So again, I can view this as a one-off situation. So this is a place where fish was gathered and habitat was assessed. And so you can see the date, you can see the data as a single time point. There are a couple of functionalities here that allow you to download that data. So we can click on the download button and choose a date range. We can also choose specific sites. So for example, if I want to look at Hewitt Fork 010, I'm going to go first to the Raccoon Sims Huck 10, and then the Elk Fork Raccoon Creek Huck, Raccoon Sims Huck 8, then the Elk Fork Raccoon Creek Huck 10, then the Hewitt Fork Huck 12, and then HF010. And then I can click on either chemical download or biological download and download all of the data for that site for all of the records we have. And that will open up as an Excel file that you can then manipulate or import into R or analyze in Excel. There's also some graphing capabilities within the site itself. So if I click on graph your data, I can then search by Huck to choose what data point I want to look at. So again, I'm going to go to HF010 and submit. I can add additional sites. So the next site upstream is 039. So I could select both of those, right? And so these can then show up here. I can also look at different parameters. So I'm going to expand this window so I can see it better. And maybe I want to look at, so this is pH, but maybe I want to look at conductivity. And so this is going to tell me the number of samples and the average values per site. And then over time, it's going to show me for each of those sites what the values were, what values were measured at those sites. And so you can see, on average, we're talking about, values between 400 and 500 microsiemens per centimeter, but with peaks almost to 1,000, depending on what site we're at. And you can see the difference in peak between the red, which is the further downstream site, and the blue, which is the further upstream site. And so this can suggest things about the time series of data. One of the things, we can also zoom in on specific years and get more resolution on that data. We can look at pH as well, along with other parameters. But what you can see from the pH data is that at this furthest downstream site, our earliest measurements in the 1990s were around a pH of 4, whereas our newest measurements, going into this year, are almost a pH of 7. So you can see the improvement in the water chemistry that we've achieved through treatment projects. And so this allows for just some quick graphing of data and to visualize some of the trends. One of the other pieces of functionality of this database is something called the River Mile Maps. So I'm going to go to the pan zoom tool so that I can just move this around. And I have an option to click on what layers are visible, and I can click on River Mile Map. And so this is a little slow because these are digitized paper maps that have been geo-referenced to their location. And so these are the river mile maps that Ohio EPA bases river mile locations on for the state of Ohio. And so by doing this, we can now figure out exactly where our site lies in space. And so these river mile maps show the river mileage where the confluence lies. So we can see that Hewitt Fork flows into Raccoon Creek at river mile 89.54. And then if we look upstream, we can see HF010, so this downstream site at Moonville Tunnel, is just downstream of 0.9 miles from the mouth. So each of these tick marks is 0.1 miles with a heavier tick mark at a full river mile. As you can see, 1 river mile, 2 river miles. If we go further upstream, we'll get to 3 river miles right here. And then there's usually a mark of what river mile each tributary joins at. So like this little tributary right here flows into Hewitt Fork at river mile 2.6. So this can be a really helpful tool when you're trying to figure out the river mileage of a specific point. So these are some of the key functionalities of watersheddata.com. I recommend that you explore this tool and explore some of the additional functionalities that you might be able to benefit from for your work.